Hi everyone, welcome. Today, I'd like us to look at networks, and look at networks, we'll look at definition of some terms. And before I begin, when we talk about a network, you can equally see a road network linking from one street to the other, from one town to the other. Look, you have internet network as well. So you mostly see how objects or things are connected to each other. And these terms that are important, we have a vertex, or also called a node. A node is a point or small circle that represents the position of an object or thing on the graph of a network. You have an arc, which is also called an edge. It's a line or curve that represents the path or route in the graph of a network. We equally have the degree of a vertex. The degree of a vertex here simply refers to the number of arcs connected coming to that vertex. And talking about vertices, we have an odd vertex. We have an even vertex. Odd vertex is a vertex in which the arcs going there produce an odd number. Let's say if you have 3 arcs going to a vertex, you say that's an odd vertex. If you have 5 arcs going to it, say it's an odd vertex. For it to be even, the number of arcs going to that vertex is an even number. You equally have directed networks. That's a network whose arcs are drawn using arrows to indicate the directions. We have a traversal network. Traversal. This is a network which you can draw following the arcs or the edges once. Okay? Thus you can trace the path passing through all the vertices without tracing an arc on an edge more than one time. Another way of verifying that a network is traversable is that it has only even vertices or exactly 2 odd vertices. Take note, a traversal network has exactly 2 odd vertices or has only even vertices. Then we can have an isolated network that's with 0 degree in a circular form. You can equally have a weighted network or a weighted graph where you see all the edges have numbers. Those numbers can represent the distance, can represent cost, can represent time. Okay? Also, one very, very important aspect when you are calculating dealing with networks, we must note Euler's formula where we have the number of regions is equal to the number of edges minus the number of vertices plus 2. The number of closed regions will be number of edges minus number of vertices plus 1. That said, I'd like us to practice to really understand what we are talking about. And I have this network here for us to answer some questions. Let's listen to the questions attentively. So considering the network below, state the number of vertices, edges, closed region, and regions. How many vertices are here? Let's count together. 1, 2, 3. There are 3 vertices. How many edges are there? Or arcs? 1, 2, 3. 1, 2, 3, 4. Okay, so there are 4. How many closed regions are there? When we talk about a region simply refers to the area covered by 2 arcs or by arcs, and must not be 2 area bounded like here. This is a region. This is a region. So the closed regions, the number of closed regions, 1, 2. Now when you ask the number of regions, when you must take the closed and add 1 to it, because the number of regions in total 1, 2, and 3. That's 1, 2, then the outer region is inclusive. That gives 3 regions. Okay. Now, you can still be asked, state the degree of each vertex of this network. State the degree of each vertex of this network. Okay. The degree of each vertex. Let's look at this first one. How many arcs are coming there? 1, 2, 3. Alright. It is of degree 3. Okay. Now, let's look at this one. How many are there? This other vertex? 1, 2. So looking at this vertex, we have this network coming towards it 1, 2, and this one 3. There are 3. And this one, the ones coming to it directly, they have 1, 2. Okay. And you can be asked the questions. State with reason whether or not the network is traversal. State whether the network is traversal. How do we verify if it's traversal? If it's a traversable network. We said for it to be traversal, to be a traversal network, that's exactly 2 odd vertices. And we can see that we had the first 2 vertices that we checked, they had degree 3. That's odd. Okay, that's an odd vertex. So there were 2 odd already, 2 odd vertices. That makes it traversable. Again, if we want to trace it, we can trace it well without, if I start here, I can trace this network all here and back to this point without repeating. See, I trace here, leave here, back to this point without crossing and going back again. That makes it traversable. Okay, that's it. To practice again and again, I would like to look at a question that applies Euler. A network has 5 vertices and 3 closed regions. Find the number of vertices, find the number of edges of the network. A network has 3 vertices. If we want, when using Euler, 3 vertices, okay, and 3 closed regions. So we use the second one, 3 closed regions. We have 3 is equal to number of edges minus how many vertices? Again, 5 plus 1. So when you do that, you have number of edges will be 7. You got negative 5 plus 1, negative 4. Cross will be 3 plus 4, 7. So it gives us 7 edges. And the number of regions of the network. Number of regions. They do not say close. The number of regions is number of edges minus number of vertices, right? That's 5 vertices plus 2. So we have 7 minus 5, 2, 2 plus 2, 4. There are 4 regions. And you can equally be asked to draw the graph of that network. As to draw that network. How do we draw it? It has 4 regions, 5 vertices. Okay? That's fine. Let's see what you can do. Let's see. Let's indicate the vertices. There are 5. We have here 3 already. This one, if you leave this like, okay, that's only 4. Can include that. And how many edges? 7. Let's be linking 1 edge, 2, 3, 4, 5. 5. It says 7. We have to add 1, 2. So we see that we have 5 vertices, 7 edges. Okay, let's check. So 4 regions. 1, 2, 3. Close region, then the outer part. That makes 4 regions in total. So that's how the second question can be interpreted. With this, you'll be able to master aspects that have to do with network. So having drawn that, a question can equally be asked. Is this network, is this a traversal network? You can check by verifying the vertices, or let's start here and see. If I start here, if I want to trace it, can I pass through all this? I go follow this vertex, go through, back here, passing through those arcs. You verify again, you verify using by checking, okay, the number of vertices for each. That's the degree of each vertex. From there, you do just like it has been done in the first case. Alright. Thanks for following up. Have a great time.